Hi, and welcome to Calculus 30 with Miss Verity. Today we're looking at 1.4, solving inequalities. So the ability to solve inequalities is going to be required later in our course, so we are going to practice those. So here are a list of 8 inequality properties that we're going to look through and use. So you can pause, take a minute, read them on your paper. I'm just not going to read them to you. So solving inequalities. Linear inequalities have one variable and the degree is 1. So we're going to solve by isolating our variable. Apparently we don't have an equation written here, but that equation is not that. 3 over 2x minus 2 times 5 plus x, which is greater than 4/3 x minus 10. So solving, we're going to start by distributing. 3 over 2x minus 10 minus x is greater than 4/3 x minus 40 over 3. So fractions, top with top, bottom with bottom. All right, so let's get all our x's onto one side. Oh, oops, that should be a 2x. So 3 over 2x minus 2x minus 4/3 x is greater than 10 minus 40 over 3. I feel like at this point we would like to work fraction smart, so we could multiply everything by a least common multiple, which would be 6. So multiply by 6, by 6, by 6, by 6, by 6. So that leaves us with 9x minus 12x minus 8x is greater than 60 minus 80. Well, so now we don't have any fractions, which that's always a great time. So 9 minus 20 is negative 11x is greater than negative 20. Divide both sides by negative 11. The one thing to remember is when you divide or multiply by a negative number, your inequality sign switches. So that reduces to be 1, but now we'd have x is less than positive 20 over 11. We are writing all of the solutions to this. So when we say x is less than that, we would say from negative infinity to 20 over 11. It wasn't equal to, so we're going to use a round bracket. Next up, solving double linear inequalities in one variable. So when you have a double inequality, basically meaning you have 2 inequality symbols in your equation, we are going to end up with 2 scenarios. We have negative 8 is less than or equal to 2 minus 5x. And we also have the other side, which is 2 minus 5x is less than or equal to 17. So solving on our left-hand side here, we can subtract 2 to both sides, get negative 10 is less than or equal to negative 5x. If we divide both sides by negative 5, we're going to get 2. Our inequality will switch directions, x. On our other side here, we would have negative 5x is less than or equal to 15. Divide by negative 5, we get x, our inequality switches because we divided by a negative, negative 3. So what we are looking for, if we were to have a number line, we have x is less than 2, so if 2 sits right here, we have x is less than that. But we also have at negative 3, x is greater than that. So when you have your double inequalities, you are looking for the intersection between the two areas. So in our case, that is from negative 3 to 2. Those are both inclusive, so we would give it square brackets, and that would be our solution. For B here, so again, we've got 2 scenarios. So 0 is less than pi over 3 minus 3 over 4x, and we've got pi over 3 minus 3/4 x is less than or equal to 2 pi. So starting our solving journey, we are going to, I'm just going to add 3 over 4x to both sides. So 3 over 4x is less than pi over 3. I'm going to multiply both sides by 4/3 to get rid of my fraction, so that will reduce. Remember, you could also divide by 3/4 on both sides, but if you're dividing by 3/4, you're still at the end of the day going to be multiplying by 4 over 3. The other thing you could do is start by multiplying 4 to both sides and then dividing by 3 in a separate step. So x is less than, we've got 4 pi over 9. Remember, pi is just a number, 3 and a bit. On this side, -3/4 x is less than or equal to 2 pi minus pi over 3. So we want a common denominator. We would have 6 pi over 3 minus pi over 3. So that would give us 5 pi over 3. So -3/4 x is less than or equal to 5 pi over 3. We're going to multiply both sides by -4/3. So that would reduce. We get x. We multiplied by a negative though, so our inequality is going to switch. We would have -20 pi over 9. So great number line in the sky. To find our answer, we have x is less than 4 pi over 9, but it is bigger than -20 pi over 9. Honestly, without a number line, we could probably just go, well, we know it's going to be bigger than or equal to -20 pi over 9. It's a negative number. It's going to be the smallest. And we're going all the way up to 4 pi over 9. There we go. So solving inequalities using the reciprocal property. So the reciprocal property states that if two numbers have the same sign and the first number is less than the second number, then the reciprocal of the first number will be larger than the reciprocal of the second. So what does that actually mean? So if we take we're still going to take both sides. So we have -6 is less than 12 over 1 minus x, and we've got 12 over 1 minus x is less than -2. So our inequality, our reciprocal property is basically if we take the reciprocal of both sides, so -1/6 and 1 minus x over 12, it's going to be true if we flip the inequality. So now we can solve that. We can multiply both sides by 12. We can say -2 is greater than 1 minus x. If we add x to both sides and we add 2 to both sides, we get x is, not equal to, x is greater than 3. On our other inequality, so again, take the reciprocal of both sides. Our inequality changes and we would have -1/2. Multiplying both sides by 12 to solve, we get 1 minus x is greater than -6. If we add x and add 6, we get 7 is greater than x. So x is less than 7. So if 7's here, x is less than that. But x has to be bigger than 3. So we know our answers will be between 3 and 7. Okay. So graphical solutions of inequality. So from a graph of a function, it's easy to determine the values of x for which f of x is greater than 0, meaning f of x is positive, since the parts of the graph where y is greater than 0 are above the x-axis. So if f of x is equal to 0, then y is equal to 0, and you're looking for x-intercepts. And if f of x is less than 0, meaning if our y is negative, that's going to be below the axis. So in this function, we are given a graph. We want to determine the values of each. So where f of x is equal to 0, that is basically our x-intercepts. And if we read from the graph, that appears to be at -2, at 1, and at 3. So -2, at 1, and 3. Where f of x is less than 0, so that's where we're looking for where our function is negative. Well, that is right there, and this section right here. So on our graph, we would say, starting on the left-hand side, that is from -infinity to -2. We're not going to include that one because technically at -2, it is not less than, it is equal to. Or we could be from between 1 to 3. Where f of x is greater than 0, that's where our function is positive. And so that's in this space right here and in this part right here. That's where all of our y values are 0. So that is between -2 and 1, or we could also say that is from 3 on forever. So we're going to solve the following inequality without a calculator. Absolutely. Solving the inequalities, we would be looking for, or we would need to find where our function goes to 0. So we could factor multiplies to be 14, adds to be 6. Well, our factors of 14 are 1 and 14 and 2 and 7, and in no combination does that add to 6. So we can use our handy dandy quadratic formula. We can say x is equal to -b, so +6 plus or minus the square root of -6 squared minus 4ac all over 2a. So doing the math on our function, we get +6 plus or minus the square root of 36 minus 56. Ooh, we can see right there without even finishing, if we subtract those, we're going to get a negative number. So that means our function never goes to 0. Which leaves us with two options. Either our function is doing something like this, where it's positive the whole time, or it's doing something where it's negative the whole time. How we determine that? Our a value. If our a value is positive, then our function is positive. So to solve this, our function is always positive and it never goes to 0. So x is the element of all real numbers. There's no solution in which it's always positive, basically. You could also say -infinity to +infinity. That would also be an acceptable answer. So solving inequalities using sign analysis. So when we're using sign analysis, basically, if we set our function equal to 0, this tells us if we're looking for positives or negatives. So in this case, we are looking for where all of our y values are negative. So for sign analysis, we need to factor. So multiplies to be -6, adds to be -1, x minus 3, x plus 2 is less than 0. So setting up our sign analysis, x minus 3, x plus 2. We go to 0 at -2 and at +3. So this one goes to 0 here, this one goes to 0 here, negative, negative, positive, negative, positive, positive. So overall we're positive, negative, and positive. We were looking for where we are negative, so that would be between -2 and 3. We're going to leave B, and we will do C. All right, so this function, if we're doing sign analysis, we're going to factor. So factoring our denominator, we want x minus 4x plus 3 is less than or equal to 0. Less than or equal to 0 just means we are looking for negatives again. When we put this into our sign analysis, we write down all of our factors. So we go to 0 at -3. We go to 0 at 2 and at 4. So zeros here, here, and here. So negative, negative, positive, positive, negative, 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 positive, negative, positive, positive, positive. So overall positive, negative, positive, negative. We also know we have asymptotes at 4 and -3, and that comes from the fact that our denominator goes to 0 at those points. So we know we for sure can't equal those. So where we are negative from -infinity to -3. Can't be inclusive. A, because we go to 0, B, because there's an asymptote. And we are also negative from 2 to 4.